Hello, learners. Today, I want to start about a topic in Form 2. We call it the fluid flow. That's Form 2 physics. We want to study this, but we want to have a look at what you call the Bernoulli's principle. What is that? So, as learner of water in physics, because this is a holiday, so it's good us to learn together and understand what is Bernoulli's principle. So in this case, as you can see, this man, we call it the Daniel Bernoulli, who lived in the year 1700 to 1782. He came about with this principle. We call it the Bernoulli's principle. He was talking about the variation of pressure, trying to explain exerted by a given speed. So in this case, the pressure is created depending on the speed. So in this case, the pressure is lower when the speed is higher. So I want to see how this is possible by doing what you call some of the illustration as we move in the course of this lesson. But in that case, we want also to state what is Bernoulli's principle, what this exact man trying to state when you talk about the Bernoulli's principle. He came with his own principle, which states that a fluid flowing through a tube, the sum of the pressure, the kinetic energy per unit volume, and the potential energy per unit volume of a fluid is constant. So this is the equation he was trying to say, to state. In this case, as you can see, pressure P stands for the pressure. We have the density, which stands for the that symbol, which stands for the density. We have also h, which stands for the height. We have lastly acceleration, which stands for the g, which stands for the acceleration due to gravity. So this is the equation which is trying to illustrate on that. By giving a simple illustration on that, this one we know is the pressure column, and now this is what we call the kinetic energy, but in this case it is found through the kinetic energy per unit volume, and I want to see how this volume is coming in. Remember, the kinetic energy is the same as 1 or 2 mv squared, where m stands for the mass and v stands for the velocity a given object is trying to move at. But from density, from one work, we know density is equals to mass over volume. Now I want to make m the subject, so if you want to put sides by m, we will have mass as the density times what? The volume. And now we come here to the kinetic energy. We substitute where we have the kinetic energy as what? I have, instead of writing m now, we substitute with what? With this one, where we can say it is the density times the volume, and then you multiply with what? The volume. From there we can generate an equation saying I have the density, then the volume of what? Per unit volume. So that's how we have arrived with this equation there. So as you can see, we have an illustration on this. We have a given tubes inside a fluid flowing on that.